Hello everyone, in this video I would like to show you a sort of benchmark that I put together some time ago to test the performance of the old school C malloc, realloc and free functions against the C++ new and delete operators. So here's the idea. Well, first of all, I have a struct called timer, which is basically responsible for measuring execution time. So not really going to explain this part of the code because this is not really the purpose of this video. I'm basically using the chrono library to do that. Well, here's one of the classes that I'm actually using directly in this benchmark, and this class is called my malloc class. So this is what you would typically have if you were to represent some container that contains some data. In this case it's double, so maybe some sort of array or matrix or whatever it is that you're dealing with. And also it takes one parameter which expresses its length. So if this is successful, then it assigns the length specified to the private member variable here. So this is the constructor and this is the destructor, so it checks whether this is not null, and if it's not, it frees the associated memory. So apart from that, it has an overloaded assignment operator, and this would be typical if you were to kind of overwrite one class or one instance of this class with another instance of the same class. So typically you would like to, in this case you can try with the realloc function, because what it does, if there's enough memory or enough contiguous memory to fit that data, it doesn't change the address, so it uses the same location in memory. It just kind of stretches it out, and if it does have to move the memory or put or reserve memory in a different location, then it internally copies the data associated with the initial pointer here. Okay, so if it performs the null check here, and if everything's successful, it assigns this temporary pointer to the actual pointer, which is mp data, and also updates the length of this instance of the class. And typically, as I said, what you would like to do is you would like for it to overwrite the data that is in the old instance of the class with the data from the new or other instance of that same class. And in order to do that, you could use the memcopy function. And so this is the idea, and pretty much the same functionality here, but using the C++ new operator. So we have my new class, so it reserves the appropriate amount of memory, and if it's successful, then it assigns the specified length to the member variable called mLength. Okay, and here we have the overloaded operator, which does pretty much the same thing, but it's not really possible to reproduce like 100% the behavior of the realloc function, because there's just no C++ equivalent. So what it will do is it will reserve completely different block of memory. So whether there's more memory available at the old location, it doesn't really care about that. It will reserve it in some other place. And if it's successful, then we can delete the old data, and then we can update this pointer here and also the length. And of course we can copy the new data coming from this other instance here using the memcopy function. So this is the idea. And let's go to the actual part where it tests this whole thing. So we have some functions here. The first of them is called test malloc. Then we have test new, and what it does is basically takes a vector that specifies the length of, for this parameter here. Yeah, so it can be of different sizes, just to have some variety. And yeah, first we use the malloc function. Here we have the number of instances, and we return the time it took to perform these operations. Okay, so now we have test new, which is basically the same but using the myNew class. And over here we have test realloc. So as you can guess, it tests the realloc functionality here, which is in this overloaded operator here and here. And so it initializes an instance of this malloc class, just so it can override it with another instance. So basically all it does, it kind of initializes another instance of that class and then overrides or updates the old one with the new one, and also returns the time necessary to perform those operations. And then we have the delete new approach with my new class and my other new, and basically it replaces the contents of the internal contents of the old instance with the new one, and so on and so forth, depending on the number of instances. And it also returns the time that was necessary or required to perform all those operations. And here's the main function. We specified the minimum length of this class here. So this corresponds to this argument here, and the max length, so from 1000 to 100,000. And then I'm using some random number generator using the Mersenne twister algorithm, and basically just to add some randomness to this benchmark. And the number of instances, I've set it to 10,000. Also this vector here that will hold the lengths of this for this parameter here. This parameter here. And number of runs, I set it to 12. So it's going to show us how, like, which one was faster, if it was malloc or new. And I'm just going to discard the first two samples when it comes to the overall score, because it's not too representative of what it actually or how well it can perform, it usually can be slower, those first invocations of those functions. So just to make it more realistic, discarding those two outliers, I would say, from the overall score. So, well, let's go ahead and test it. Well, it would seem that the malloc function should be faster, because more often than not, implementations of the new operator use actually the malloc function somewhere under the hood, so it would seem logical for it to be faster. But this wrapper that they offer can be so thin that maybe it will even be the other way around. But probably see that there's like a small margin, so it's almost a tie here. So I'm in release mode, 64 bits, and let's see what happens if I run it. Not sure something went wrong. Okay, so the results are here, and as you can see, the new approach turned out to be faster, like a tiny bit faster, but still. Let's run it again and see if we get any different results. Again, new is faster, but not much, like 2% or so. And now it's the other way around. It's malloc. So you can see it's the winner is not very obvious there. Almost the same, basically, or for most practical purposes, I would think that they'll be the same. So maybe let's just add the number of instances here and see if we can get any different results. Again, for some reason, new seems to perform a little bit faster, but now malloc one. But as I said, it doesn't really matter that much in this case. The difference is, for all practical purposes, I would say it's negligible. So now let's go to the other tests, which is for realloc and delete new. So we're gonna update it here, realloc and delete new. So you say realloc and delete new. Okay, as for my predictions is how it will go, as to how it will go. Well, if I comment this out, then naturally it seems that this will be slower, because if it doesn't find the block, like doesn't find enough free memory in the current block, they'd have to move to another location in memory and also copy the old data to that new location. So it does some stuff in the background. That's why by default it should be slower than a new, in this case, which basically just reserves a new block of memory, and then if it's successful, then it deletes the old data, which is not as expensive, because it probably just doesn't like actually delete the data. It just marks that region of memory as accessible. So this, I'm guessing, will be faster. So let's run it and see what happens. As I said, delete a new, in this case, this approach is noticeably faster. Let's run it again. And again, we have this performance difference. So delete new approach seems to be faster in this case. But let's say if we were to copy this data, and let's run it. Let's see what happens. For some reason now, the realloc method is faster. And again, even though it's not very different, but still kind of surprising. It makes me wonder if the code is broken here. Because if this part takes considerably more time than this part, and this is basically the same as here, then why does realloc win in that case? It's kind of hard to understand, but maybe you have some ideas, so you can leave them in the comments. As for this code, I'll try to put it in the description so that you can run it, so you can play with it, maybe change it. I may change it as well, so this is not necessarily the final version. If I spot some errors, then I probably try to edit them out. So that would be all for this video. Thank you for watching. I hope you found it useful. If you did, please subscribe to my channel so I can produce more content. Thank you and bye.